Hello everyone, my name is Radhesham Gowde and today I am presenting the Unit 6 called as Bridges, that is Introduction to Bridges. Today we will discuss classification and types of bridges, components of bridges, concept of economical span, afflex, HFL, scour depth, loads on bridges, IRC load specifications, failure of bridges in India, etc. Here are some references like Bridge Engineering by S.P. Bindra, IRC Handbooks, Traffic and Highway Engineering by J. Gargar and L.A. Hoyle, Highway Engineering by Khanna and Justo. Bridge. The drainage structure under which facilitates the communication route for carrying load or railway traffic across the obstructional and depression with or without water is called as bridge. The branch of civil engineering which deals with this design, construction and maintenance is called as bridge engineering. There are two types of bridges, major bridges and minor bridges. The, the length from 0 to 30 meters comes under the minor bridges and above that up to 120 meter comes under the major bridges. Also, they are there are there can be a distribution of types like convert, linear waterways, afflex, abutments, wing walls, piers, etc. Bridges can be classified into various types based on their following factors. Based on materials, there are masonry bridges, RCC bridges, steel bridges, timber bridges, pre-stressed concrete bridges. Bridges based on the floor can be deck type or throughout bridge. On the purpose can be highway bridge, railway bridge, and aqueduct. Sorry. Then, as a superstructure, we can distribute them or classify them as a portal frame, balanced cantilever bridge, or suspended bridge. On flood level, submersible or non-submersible bridges. Span length, culvert, minor and major, as we discussed before. Then the last one is fixed or movable. Swinging bridge, bustle bridge, or bascule bridge, or and lift bridge, etc. Then here are some images of the discussed bridges, which shows arch, tide bridge, tide arch bridge, cantilever bridge, truss bridge, beam bridge, suspension bridge, and cable bridge. Some of these are RCC bridges, and some are the steel bridges, or some are the suspended bridges. Suspended means the cables are used to stretch to take the weight of the beams of the bridge. Then the pre-stressed concrete bridge. This is a type of a bridge. The bridge having their superstructure consisting of a pre-stressed concrete members in any structural form, which support the bridge floor known as pre-stressed concrete bridge. In these bridges, the pre-stressing method, concreting method is used, in which uh, the inner reinforcement is in the form of cables which are stressed before concreting, and uh, and the concreting is done while the cables which are kept as a reinforcement are stretched already after they are released when the concrete is at rigid state. The art of the pre-stressing consists of introducing compressive stresses in the tensile zones of the members. As I said before, the pre-stressing means the cables are stressed before the concrete pouring and then released. So the tensile stressed cables will try to compress again due to its elasticity. Therefore, the the compression will be induced at the bottommost or the compression tension zone of the beam or the concrete section. Therefore, there will be collision of the compression and tensile forces, and there will be no any forces. So there will be uh, less depth required for the structure or for the section. The technique of pre-stressing checks the tendency of cracking and increase the shearing capacity of the ordinary reinforced concrete. This enables the use of thinner webs, therefore resulting having saving material, dead load, and ultimately economy in the design of the bridge. Thus, the application of concept of pre-stressing to the bridges and bridge members has enlarged the span range of the concrete bridges. These are some advantages and disadvantages. Advantages: higher load carrying capacity, reduced deflection of gutters due to the pre-stressing or the convex stressing, fewer expansion of joints, more aesthetic appearance, more effective use of precast members, maintenance cost is less, more smooth deck and high speed driving. These are disadvantages: careful supervision, special equipment for the construction, high tensile steel is required, which is more costly than the ordinary steel. Then the next type is movable bridge. Movable spans of bridges are sometimes used over the navigable channels where permanent and sufficient clear waterway cannot be provided. They are needed to order to provide a passage for a masted vessel or steamers when the bridge is to be across a navigable river or deck. In this type, the bridges are moved or rotated in vertical direction, so which the waterways can be clear or the uh, boats or the passes can use the waterway. So to clear the waterway, the bridge can be moved or rotated. There are in this type of bridges there are three more classifications: swing bridge, bascule bridge, and traverse bridge. In swing bridge consists of a balanced girders swinging around the quadrant of the circle over a pier or a pivot or on a turntable. So these bridges rotates horizontally and creates the two pathways or divides the river horizontally in two ways. Then the another is Bascal Bridge, can be raised slightly to permit the passage of the numerous small boats which, which fail to clear the closed span by small origin. They revolve around the horizontal axis in a critical position when lifted attain an upright position. Traverse Bridge can be rolled backwards and forward. They can provide with rollers on the shore which helps to position along the approach. These are like a sliding. This can be removed like a sliding uh, bridge. Then this is the transporter bridge and lift bridge. Lift bridge just gets up and gets down in the vertical direction. Then the suspension bridges. These are the bridges suspended using the cables uh, from one end to another end. These are the in the image you can see the main two cables, and the verticals are the mm, secondary cables. Secondary cables are actually loaded, and the main cables are supporting them in the tension zone. Involves factors governing choice of type of bridge. This is the main slide. The nature of the river and its bed, soil, and physical features of the site. Availability of materials, workers or funds, volume, and nature of the traffic. Time limit within which the bridge is required to be completed. Here, structures require very less time against the concreting. Whether navigation is done in the river or not, economic span length of the bridge, facilities available during the construction, facilities available of maintenance, foundation condition, climatic or strategic condition, hydraulic data and live loads on the bridge, length and width of the bridge. The numbers, this is the bridge numbering. The numbers are given in the form of fraction. The numerator denoting the number of kilometers in which the structure is suited, and the denominator the kilometer wise serial number. Sometimes you must have seen the stones near up, near or sideways on the road, showing some fractions like 1 by 15, 5 by 15, 4 by 15. It means from one location to the another location there is a road. On that specific road, how many number of bridges are there is the number below the in the denominator, means the 5 divided by 15 means there are 15 bridges on that road, and 5 means it's the fifth bridge of that road. So this is called as bridge numbering. IRC standards on loading and heavy loading. It consists of uniformly distributed load of 1.13 tons linear per linear meter of each traffic lane, plus the knife edge of load 6 tons computing bending moment and 9 tons of computing shear force. The difference is that uniformly distributed loads was increased by 0.8 ton per meter, and knife load was increased by 1 tons per inch in heavy loading. The present IRC bridge loadings are of the following three types: Class AA loading, Class A loading, Class B loading. Afflux. It is the rise in the level of the water surface of water course above the normal on the upstream side of the bridge. This rise due to the obstruction caused by the bridge abutments and piers in the water flow. Afflux is taken as a difference of levels of the downstream and upstream water surface of the bridge. The, the neutral waterway of the rivers or streams is usually greater than the water way below the bridge, which causes the afflux. You you can't see the image, but there is a drop in the depth level of the water due to the interference of the bridge.